SolidWorks leverage different mate types to fully define an assembly. Many of these mates have numerical callouts that adjust different component oppositions and orientations such as distance mates, angle mates, and more advanced mates such as limit mates. Adjusting these mates can affect aspects of the system, such as the center of mass and moment of inertia. Evaluating the mates becomes a critical process in understanding how to assembly functions mechanically, which can potentially adjust the design of components to meet a specification. In this lesson, I will demonstrate how to add mate and assembly using a drawing containing a table with mate specification. Once the mate are added, I will demonstrate how to adjust them so they are repositioned properly. Here I have a drawing sheet displaying the assembly in an isometric view, along with a table listing the different values for the mates between questions. There are 4 mates that will be adjusting between question 1 and question 2. However, these mates do not necessarily need to be created in alphabetical order. If I take a look at the table, a single distance mate need to be added as well as 3 angle mates. I'll switch over the assembly to begin adding them. Here the assembly has multiple underdefined components that are free to rotate. If I click the drag the component ball arm, the component is free slide within the slot as well as rotate the slotted arm. If I click and drag the bracket component, the bracket is free to rotate and the ball arm moves along the slot. To make this component fully defined, I will need to add the 4 mates retained in the drawing. I'll begin by adding a mate between the side face of the bracket and the face of the end of the foot of the base. I'll switch back to the drawing to see which mate this is end and according value, and I can see the mate B creates this relation value of 30 degrees. I'll switch back to the assembly, click the mate tool, click the angle mate from the standard mate tab, select the side face of the bracket and the end face of the foot. Make sure the value is set 30 degrees and click the green check. Now that the mate has been created, I want to rename it in the feature tree so that I can easily identify it when I change its value later. I'll expand the mate folder in the feature manager tree and I'll click on the angle mate shown at the bottom and rename it B. The next mate I want to add will control the angle between the slotted arm and the side face of the bracket. I'll switch back to the drawing and I can see this mate shown as mate D, which has a value of 45 degrees. I'll switch back to the assembly, enable the mate tool, select angle, select the side face of the bracket and the side face of the slotted arm, set the angle value to 45 degrees and click the green check. Now I'll rename this mate to D in the feature tree. Next I want to specify the distance between the center of the peg on the ball arm component and the center of the curve cutout on the slot. I'll switch back to the drawing and I can see this mate shown as mate A, which has a value of 50 millimeters. I'll switch back to the assembly, enable the mate tool, select distance. And in order to select the center of the peg on the ball arm component, I will need to view the temporary axis. I'll click on the hide show items drop down from the heads up toolbar and turn to view temporary axis and turn on view. Now I can select the axis of the peg in the graphics area and I can zoom in to the select the temporary axis of the curved slot cutout. Set the distance to 50 millimeters and click the green check. I'll rename the mate as A in the tree and I can turn off the temporary axis. The ball arm is now positioned within the slot, however it can still freely rotate. This is the only underdefined mate left in the assembly. I'll switch back to the drawing to add the last angle mate to fully define the assembly. The last mate is mate C, which sets the angle between the side face of the ball arm component and the end face of the slotted arm. This value of this mate is 55 degrees. I'll switch back to the assembly, select mate, select angle, click to the side face of. I'll switch back to the assembly, select mates, the ball arm, click on the end face of the slotted arm, set the angle to 55 degrees and click the green check. I'll rename this mate as mate C. This completes adding all of the mates to the assembly, and you can see that all of the components are fully defined. In the next video, I'll demonstrate how to edit these mate values, which will change the position and orientation of the component in the assembly. Now that all of the mates have been added to the assembly, I can switch their drawing to view the new mate values that I will update the assembly. Here in the drawing, I will take note of each of the value of the mates. Distance mate A changes from 50 millimeter to 75 millimeters. Angle mate B changes from 30 degrees to 85 degrees. Angle mate C changes from 55 to 130 degrees. And angle mate D changes from 45 to 15 degrees. Now that I have noted that these changes, I'll switch back to the assembly to update them. To begin updating the mates, I will make sure that the mates folder expanded in the feature tree. And I'll first update distance mate A. I'll click on the mate in the feature tree, select edit feature, and change the distance value from 50 to 75 millimeters. And I can click the green check to complete the update. Now I'll just angle mate B. I'll edit the mate and I'll change the value from 30 degree to 85 degrees. And when I click the green check, the mate is fully updated. Next, I'll adjust angle mate C. I'll edit the mate, change the value from 55 to 130 degrees. Notice that the ball arm is now positioned higher than the slotted arm. If this is the incorrect position for the component, I can use the mate alignment tools in the property manager to flip the alignment, and when I switch it, the ball arm rotates to be positioned below the slotted arm. This looks good to me, so I'll click the green click to complete the update. Lastly, I will adjust the angle mate D. I'll edit the mate, change the value from 45 to 15 degrees and click the green check. This completes updating all of the mates in the assembly.